Transmission Control Protocol, TCP. Transmission Control Protocol, TCP, is a connection-oriented, reliable protocol. TCP explicitly defines connection establishment, data transfer, and connection teardown phrases to provide a connection-oriented service. Whenever a computer wants to communicate with another computer, the communication between those two computers needs to be good and reliable, so it can guarantee that the data is received correctly. TCP segment. A TCP segment is a piece of data sent over a TCP connection. It's like a slice of a larger data stream. Components: source port address, the port number of the sending application. Destination port address, the port number of the receiving application. Sequence number, helps in ordering and reassembling segments at the receiver's end. Acknowledgement number, indicates the next expected sequence number. Flags, control information like SYN, ACK, FIN, etc., for managing the connection. Window size, indicates the amount of data the sender can accept. Checksum, helps detect errors in the segment. Data, the actual payload being transmitted. TCP packet is the combination of TCP segment with IP header information. TCP connection management. TCP is a connection-oriented protocol, which means that it first establishes the connection between the sender and receiver in the form of a handshake. After both the connections are verified, it begins transmitting packets. It makes the transmission process error-free and ensures the delivery of data. In TCP, connection-oriented transmission requires 3 phases: connection establishment, data transfer, connection termination. First, let's see about connection establishment. The TCP connection establishment process involves a series of steps, often referred to as the three-way handshake, where a client and a server establish a secure and synchronized connection before initiating the actual data forwarder. So the first step is that a computer will send a message called a SYN. Then the receiving computer will send back an acknowledgement message telling the sender that it has received the message, and then finally the sender computer sends another acknowledgement message back to the receiver, and then once this has taken place, data can be delivered. Here the client wants to make a connection with another application program called the server. The server program tells its TCP that it is ready to accept a connection. This request is called a passive open. So when a client program issues a request for an active open, a client admissions to connect to an open server tells its TCP to connect to a particular server. TCP can now start the three-way handshaking process. Fast, the client sends the first segment, that SYN segment, in which only the SYN flag is set. This segment is for synchronization of sequence numbers. The client takes a random number called initial sequence number ISN, and suppose it is 8000. SYN segment is control segment and carries no data. However, it consumes one sequence number. When the data transfer starts, the initial sequence number is incremented by 1. When we say that the SYN segment carries no real data, but we can think of it as containing one imaginary byte. Now the server sends the second segment called SYN plus ACK segment with 2 flag bits set, that is SYN and ACK. This segment has a dual purpose. First, it is a SYN segment for communication in the other direction. The server uses this segment to initialize a sequence number like 15,000 for numbering the bytes sent from the server to the client. The server also acknowledges that receipt of the SYN segment from the client by setting the ACK flag and displaying the next sequence number like 8001, which the server expects to receive from the client. Because it contains an acknowledgement, it also needs to define the receive window size 5000 for flow control. At last, the client sends that third segment. This is an ACK segment. It acknowledges the receipt of the second segment with the ACK flag and acknowledgement number 15001. Here also the sequence number in this segment is the same in the SYN segment 8000. The ACK case segment does not consume any sequence numbers. The client must also define the window size, suppose it is 10,000. In general, third segment usually does not carry data and consumes no sequence numbers. Data transfer. TCP/IP provides a mechanism for transferring data between two applications, which can be running on different computers. The transfer of data is bidirectional, provided that the TCP/IP connection is maintained and no data is lost. The sequence of the data is kept. After a connection is established, the client sends 2000 bytes of data in two different segments. First segment contains sequence number 8001 and acknowledgement number 15001 in continuation of connection establishment. Here data you are transferring are with byte numbers 8001 to 9000. Second segment contains sequence number 9001 with same acknowledgement number 15001 with 1000 bytes of data from 9001 to 10000. Now the server may send 2000 bytes in one segment with sequence number 15001 along with acknowledgement number 10001 because the server has successfully received bytes up to 8000. It gives the number to each byte like 15001 to 17000. Further, client can send the segment containing sequence number 10000 and acknowledgement number 17001 with receiving window 10000. Connection termination. The party wishing to terminate the connection sends a TCP segment with the FIN finish flag set to the other party. The FIN flag indicates that the sender has no more data to send. First we will see three-way handshaking for connection termination here. The client TCP, after receiving a close I command from the client process, sends the first segment, that's a FIN segment in which the FIN flag is set. Note that a FIN segment can include the last chunk of data sent by the client or it can be just a control segment which consumes only one sequence number. The server TCP, after receiving the FIN segment, informs its process of the situation and sends the second segment like FIN plus ACK segment, to confirm the receipt of the FIN segment from the client and at the same time to announce the closing of the connection in the other direction. This segment can also contain the last chunk of data from the server. If it does not carry data, it consumes only one sequence number. At last, the client TCP sends the last segment, an ACK segment, to confirm the receipt of the FIN segment from the server. This segment contains the acknowledgement number, which is 1 plus, then the sequence number received in the FIN segment from the server. This segment cannot carry data and consumes no sequence number. Half close. TCP allows you to close each direction of the connection independently. A TCP connection is said to be half closed when it is closed in one direction and still open in other direction. In TCP, one end can stop sending data while still receiving data. This is called a half-close. Either the server or the client can issue a half-close request. Such implementation is required when the server needs all the data before processing can begin, for example sorting of data. When the client sends data to the server for sorting, the server needs to receive all the data before sorting can start. This means the client, after sending all data, can close the connection in the client to server direction. However, the server to client direction must remain open to return the sorted data. The server, after receiving the data, still needs time for sorting. Its outbound direction must remain open. The data transfer from the client to the server stops. The client half closes the connection by sending a FIN segment with sequence number like X and acknowledgement number Y and setting FIN bit to 1.